Hello everyone, I am Advait Desai
Hi, I'm Prithvikiran Premkumar.
and we are here to present our project entitled Data Drift Detection. So I'll be sharing my screen and let's start with the presentation. So, what exactly is data drift? Data drift is something which refers to gradual change in statistical properties which causes ML models to perform poorly because the real world inputs no longer match the certain given inputs. And if the drift is not detected early, it makes ML model predictions inaccurate. So, this could lead to inconsistencies in the larger side in various MNCs, and this concept is basically used by big MNCs such as Amazon and Netflix. So, our project goal is to build a system where we'll be identifying baseline and new data sets, and we'll be detecting the drifts between them. And we have to provide, we aim to provide alerts by Gmail. So moving on to software and hardware components, these are some of the software and hardware components we have used, and you would better understand it with architecture and the flow of our project.
Hi, this is Prithvi, and I'm here to explain the architecture. As he discussed, data drift is the change in the distributional patterns of data. And here we are dealing with textual data, simulating search queries, and we would be tracking metrics like semantic relationships between two texts, out of domain lexical analysis, and topic drift. And we'll be tracking metrics like PSI and KL divergence to, find the relationships between texts. And now regarding the architecture, so the client, which is a UI, and the UI is connected to a fast API server, which uploads the files to an object storage. And there are also files which are, pre-uploaded in it. We are providing you an interface where you can select your baseline dataset and your drift dataset, and you can compare how different are the two, CSVs. Here we are using CSVs, and in our implementation, we have our baseline dataset is based on Stack Overflow queries, and our drift datasets are synthetically generated with various ratios of drifts in semantic relationships and lexical relationship and so on, right? So the Google PubSub is a queuing system, message queuing system here, which passes the data sets to our diff detection service for the metrics to get computed. And after we compute the metrics, that's being uploaded to the Postgres DB for further analysis. And simultaneously, our Slack is being connected to a Gemini for a small descriptive way of the metrics which has been computed, and a Gmail alert. Moving on. Regarding the debugging, we had to ensure that the PubSub, regarding the PubSub debugging, it has to be like done with queues, and the Google authorization was one thing which we had to, ensure. And Drift Engine, we had to have the, you know, uh, optimal embedding model for it, the right embedding model for it. That was a key component in the debugging part, and the metric computation was also key here. And regarding the min IO debugging part, we had to ensure the data sits well as buckets. It actually, the post request works. So that was the major debugging part in that module. Database, again, table, population was the key, aspect of it. Other issues are like Slack and Gmail. While debugging that or while implementing, we had to ensure the environment variables are fine for authentication, and the webhook URL in Slack was correctly placed. And this was the entire debugging process. Moving on.
So moving on. So moving now on to the learning outcomes, I had several learning outcomes as this was my first ever full stack project where I implemented a proper backend, front end, as well as integrated it with cloud services. So this was my first ever ML ops project as well, where I built the pipeline using UI, API storage, as well as messaging and worker components. And so moving further, we have future enhancements. So my teammate would be talking about it.
So we had Dockerized the entire application, and here the scope of future enhancements would be to connect it to real-time data and to detect drifts in real-time data. And also, we can also connect it to an intelligent system, or rather an LLM, which actually addresses or gives actionable insights based on the data drift. That could be one part which we have thought of future enhancement. And of course, like making it more, scalable in terms of in terms catering to the production environment. Yeah, I feel those are the things. And now we'll be moving to
So
the
thank
demo.
you.
Thank you. Yeah.
Yeah, thank you so much for listening to our presentation. So now let us begin with a simple demo. Let us first, so this is our UI in which we have to upload the baseline. So let us first begin with uploading our baseline dataset at first. So and then let us upload a drift dataset. So let's say we are checking for semantic drift. Let's run it. And now we have uploaded it successfully to pub or sub. So here in our Google's interface, you can see that this is what is being managed. This is Google pub or sub. But let us focus at some important aspects of project rather than doing this. Now this is the fast API which we have run it, and this is the workers file which we are running right now, and here the results are printed, as well as let us now fetch results. Now you can see there's alerts sent to our email as well, which I will be showing at the earliest. And the Minayo, this is the Docker image that has been created. So there are many Docker images, but these three are created for our project, and these is seen here where it is created. And now let us verify this in our front end part. So first, before that, I would like to show the Minayo console where we are seeing the CSV files as well as the drift datasets files here, baselines as well. And now let us move on to our front end to fetch the results. So now let us fetch latest results. So here we can see we are getting the results we have obtained from our worker, and here is the visualization will take some time, but here we are getting visualization as well. And now I'll like to show you the email as well. In my email I have got the alert which is currently on my mobile. Let me just switch it on at the earliest. So here is the drift email I got because the drift detected was very high, and you can see all the metrics here. So now moving on, I would also like to showcase the PostgreSQL and Slack notifications.
So as you can see, this is our Postgres DB, where the drift semantic.1 file was uploaded for drift detection, and you can see it has been populated here. So our DB works fine, storing the metrics. Next, I would like to show you our Slack integration, where you could see that there is also a Slack notification here. So that's our project. We have integrated the components required from Minayo PubSub, Dockerizing it, and the drift detection metrics stored at the Postgres DB and with Gmail and Slack notification. This is our project. Yeah.
So thank you so much everyone for paying attention or having a look at our video. Thank you and have a great day.
Yeah. Thank you. Yeah.